What defines low-energy nuclear reactions? LENR, 4 cold fusion. Imagine a process where nuclear reactions happen at room temperature, not in the blazing heat of a star or a nuclear reactor. That's what scientists call low-energy nuclear reactions, or LENR. These reactions are a key part of the cold fusion puzzle, a phenomenon that has puzzled researchers for decades. Unlike traditional nuclear fusion, which needs millions of degrees of heat to force atoms together, LENR occurs under surprisingly mild conditions. Usually, it takes place inside metals loaded with hydrogen isotopes, like palladium or nickel. These metals act like tiny reactors, where the atoms are packed so tightly that nuclear reactions might happen without the extreme energy normally needed. The idea of cold fusion burst onto the scene in 1989 when researchers claimed they produced excess heat from electrochemical cells using palladium electrodes and heavy water. The heat was more than chemical reactions could explain, hinting at a nuclear process. But the idea faced skepticism because it defied what we know about nuclear physics. The main challenge is that the nuclei involved don't seem to fuse in the usual way, and there's no clear evidence of the radiation or chain reactions typical of hot fusion. Instead, LENR might involve other subtle forces or mechanisms, like neutron interactions or resonance effects within the material's microstructure. In these special environments, tiny cracks or defects in the metal might help nuclei get close enough to interact. Some theories suggest that hydrogen or deuterium atoms, heavy hydrogen, can form resonance states or interact through weak forces that allow nuclear changes at low energies. This could produce nuclear byproducts like helium, tritium, or even neutrons, but results are often inconsistent. Sometimes experiments show excess heat, other times they don't, making the science seem unpredictable. The key features that define LENR include the fact that it happens at room temperature or slightly above, which is a huge contrast to the millions of degrees needed for conventional fusion. It can produce energy levels that are much higher than chemical reactions, but without the intense radiation or chain reactions. The process often depends on the material's microstructure and how hydrogen isotopes are loaded into the metal. For example, palladium loaded with deuterium or nickel with hydrogen are common setups. In the realm of strange science, LENR is a curious phenomenon. Its results are quirky and often inconsistent, which makes scientists question whether they're seeing real nuclear reactions or some unknown process. Still, the potential is huge. If we can understand and control LENR, it could lead to clean, safe, and cheap energy sources that don't produce harmful waste. This idea excites many researchers because it hints at a new way of tapping into the universe's hidden forces. So, in simple terms, LENR for cold fusion is about nuclear reactions happening at low energies inside special materials, producing more energy than chemical reactions alone. It's a mysterious and puzzling area of science that challenges what we think we know about the forces that govern the universe. While it remains controversial, the possibility of harnessing such reactions keeps the curiosity alive in the world of unexplained physical and cosmic phenomena.